Question 1. Compliance review shows that the risk assessment process for the DB2 for Z/OS environment has not been updated in over 2 years and primarily focuses on historical security incidents. What is the most appropriate next step to ensure robust data protection and regulatory adherence? Option A. Conduct a comprehensive, current risk assessment that identifies critical data assets, analyzes potential threats and vulnerabilities specific to the DB2 for Z/OS environment, and evaluates the likelihood and impact of these risks to determine appropriate mitigation strategies. Option B. Implement additional security monitoring tools based on general industry best practices for database security, assuming this will cover any potential gaps. Option C. Update the risk assessment documentation to reflect the existing security controls and assume that the lack of recent incidents indicates the current process is sufficient. Option D. Focus on reducing the cost of existing security controls to free up budget for other IT initiatives, as the current controls have not led to any recent breaches. The correct answer is A. Conduct a comprehensive, current risk assessment that identifies critical data assets, analyzes potential threats and vulnerabilities specific to the DB2 for Z/OS environment, and evaluates the likelihood and impact of these risks to determine appropriate mitigation strategies. Explanation. Scenario analysis. This scenario presents a common challenge in database administration, balancing the need for robust security and data integrity with the operational demands of a production DB2 for Z/OS environment. The compliance review has identified a potential weakness in the risk assessment process, specifically concerning the identification and mitigation of threats to sensitive data. The professional challenge lies in accurately evaluating the likelihood and impact of various threats, and then selecting appropriate, cost-effective controls that align with IBM DB2 for Z/OS best practices and relevant regulatory frameworks. The complexity is amplified by the Z/OS environment, which has its own set of security considerations and operational nuances. Correct approach analysis. The correct approach involves a systematic and documented risk assessment process that considers both internal and external threats. This includes identifying critical data assets, analyzing potential vulnerabilities, e.g., unauthorized access, data corruption, denial of service, estimating the likelihood of these threats occurring, and quantifying their potential impact on the business. Based on this analysis, appropriate controls are then selected and implemented. For DB2 for Z/OS, this would involve leveraging native security features like RACF or equivalent, auditing capabilities, encryption, backup and recovery strategies, and change management processes. This approach aligns with general IT governance principles and specific data protection regulations that mandate risk-based security measures. It ensures that resources are allocated effectively to address the most significant risks, thereby protecting sensitive data and maintaining operational continuity. This methodical process is crucial for demonstrating due diligence and compliance. Incorrect approaches analysis. One incorrect approach is to solely focus on known, past incidents without considering emerging threats or potential future vulnerabilities. This reactive stance fails to proactively identify and mitigate risks, leaving the system exposed to novel attack vectors or unforeseen circumstances. It represents a failure in due diligence and a disregard for the dynamic nature of the threat landscape, potentially violating regulatory requirements that mandate a forward-looking risk management strategy. Another incorrect approach is to implement security controls based on industry best practices without a specific risk assessment tailored to the organization's unique environment and data. While industry best practices are valuable, they may not adequately address the specific risks faced by this particular DB2 for Z/OS installation. This can lead to over- or underprotection, inefficient resource allocation, and a false sense of security, failing to meet the specific compliance obligations tied to the actual data being processed. A third incorrect approach is to prioritize cost savings over security effectiveness when selecting controls. While budget constraints are a reality, making security decisions solely on the basis of the lowest cost without a thorough evaluation of their risk mitigation capabilities is a significant ethical and regulatory failure. This can lead to the implementation of inadequate controls that do not sufficiently protect sensitive data, potentially resulting in data breaches, financial losses, and reputational damage, all of which would be viewed unfavorably by regulatory bodies. Professional reasoning. Professionals should approach risk assessment with a structured methodology. This involves 1. Asset identification. Clearly define what data and systems are critical. 2. Threat identification. Brainstorm all potential internal and external threats. 3. Vulnerability assessment. Identify weaknesses that threats could exploit. 4. Likelihood and impact analysis. Estimate the probability of a threat occurring and the severity of its consequences. 5. Risk evaluation. Prioritize risks based on their likelihood and impact. 6. Control selection. Choose appropriate security controls that mitigate prioritized risks. 7. Documentation and review. Maintain detailed records of the assessment and regularly review and update it as the environment and threat landscape evolve. This systematic process ensures that decisions are data-driven, justifiable, and aligned with both business objectives and regulatory mandates. Question 2. Governance review demonstrates a potential for unauthorized data access within the IBM DB2 for Z/OS environment due to broad user privileges. As the DBA responsible for data security and compliance, which of the following actions best addresses this identified risk while adhering to best practices for data governance? Option A. Implement a comprehensive review and refinement of DB2 security profiles and authorization mechanisms, enforcing the principle of least privilege for all user access to sensitive data. Option B. Focus solely on strengthening network firewalls and intrusion detection systems to prevent external threats from accessing the DB2 system. Option C. Advise management that the current security measures are sufficient and that the governance review's findings are likely overstated. Option D. Immediately revoke all user access to critical data tables until a new, complex authorization scheme can be designed and implemented over an extended period. The correct answer is A. Implement a comprehensive review and refinement of DB2 security profiles and authorization mechanisms, enforcing the principle of least privilege for all user access to sensitive data. Explanation. Scenario analysis. This scenario presents a common challenge in database administration, where a recent governance review has identified potential risks related to data access and security within IBM DB2 for Z/OS. The challenge lies in balancing the need for robust security controls with the operational requirements of the business, ensuring that authorized users can access data efficiently while preventing unauthorized access or data breaches. The DBA must interpret the findings of the governance review and translate them into actionable security measures within the DB2 environment, considering the specific regulatory framework applicable to the exam's jurisdiction. The complexity arises from the need to understand the implications of various security configurations and their impact on compliance and operational efficiency. Correct approach analysis. The correct approach involves a systematic review of existing DB2 security profiles, authorization mechanisms, like RACF or equivalent Z/OS security products, and audit trails. This includes examining granular object privileges, user group memberships, and the principle of least privilege. Implementing stricter access controls based on the principle of least privilege, where users are granted only the minimum permissions necessary to perform their job functions, directly addresses the identified risks. This aligns with best practices for data security and is often a requirement under various data protection regulations, e.g., GDPR if applicable to the exam's assumed jurisdiction, or similar U.S. federal/state regulations if that is the implied context. Regularly reviewing and updating these profiles, coupled with robust auditing and monitoring, ensures ongoing compliance and proactive risk mitigation. This approach is best professional practice because it is proactive, evidence-based, and directly addresses the identified governance concerns by strengthening the security posture of the DB2 environment. Incorrect approach is analysis. One incorrect approach is to dismiss the governance review findings as overly cautious or to implement only superficial changes without a thorough understanding of the underlying risks. This fails to address the identified vulnerabilities and leaves the organization exposed to potential security breaches and regulatory noncompliance. It demonstrates a lack of due diligence and a disregard for established governance principles. Another incorrect approach is to implement overly restrictive security measures that cripple legitimate business operations. While security is paramount, it must be balanced with usability. Blanket denial of access or overly complex authorization procedures can lead to operational inefficiencies, user frustration, and potentially workarounds that bypass security controls altogether, creating new, unforeseen risks. This approach fails to consider the practical impact on the business. A third incorrect approach is to rely solely on perimeter security without addressing internal access controls. While firewalls and network security are important, they do not protect against insider threats or compromised credentials. A comprehensive risk assessment must consider all potential attack vectors, including those originating from within the trusted network. Focusing only on external threats ignores a significant portion of the risk landscape. Professional reasoning. Professionals should approach such situations by first thoroughly understanding the scope and findings of the governance review. This involves engaging with the governance team to clarify any ambiguities. Next, detailed assessment of the current DB2 security configuration should be performed, mapping existing controls against the identified risks. The principle of least privilege should guide the implementation of any new or modified security policies. This requires careful analysis of user roles and their data access needs. Regular auditing and monitoring of access logs are crucial for detecting anomalies and ensuring ongoing compliance. Finally, a feedback loop with the business stakeholders and the governance team is essential to ensure that security measures are effective without unduly hindering operations. This iterative process of assessment, implementation, monitoring, and review is fundamental to effective risk management in a regulated environment. Question 3. Assessment of the most appropriate immediate response to a newly discovered critical security vulnerability affecting IBM DB2 for Z/OS, where the vulnerability could potentially expose sensitive customer data, requires careful consideration of several potential actions. Which of the following approaches best aligns with professional best practices and regulatory expectations for a DB2 DBA on Z/OS? Option A. Schedule a full system maintenance window to apply the patch, accepting the risk of the vulnerability being exploited until the scheduled downtime. Option B. Focus solely on isolating the affected DB2 subsystem from the network to prevent external access, deferring any patching or remediation until a later, less critical period. Option C. Immediately apply the latest available patch from IBM without further analysis, prioritizing system security over potential short-term performance impacts or compatibility issues. Option D. Initiate a comprehensive risk assessment to understand the vulnerability impact on data integrity and confidentiality, evaluate potential mitigation strategies, and consult with security and compliance teams before implementing any corrective actions. The correct answer is D. Initiate a comprehensive risk assessment to understand the vulnerability impact on data integrity and confidentiality, evaluate potential mitigation strategies, and consult with security and compliance teams before implementing any corrective actions. Explanation. This scenario presents a professional challenge because the DBA must balance the immediate need for system availability with the long-term implications of data integrity and compliance. The core of the challenge lies in understanding the potential impact of a security vulnerability on sensitive data and the regulatory obligations associated with protecting that data. The DBA's judgment is critical in selecting an approach that mitigates risk without causing undue disruption or violating established protocols. The correct approach represents best professional practice because it prioritizes a thorough risk assessment before implementing any changes. This aligns with general IT governance principles, and within the context of Z/OS and DB2, implies adherence to IBM's recommended practices and potentially internal corporate security policies. A systematic risk assessment allows for the identification of critical data, the potential impact of the vulnerability, and the evaluation of different mitigation strategies. This proactive and informed decision-making process minimizes the likelihood of unintended consequences, such as data corruption or further security breaches, and ensures that actions taken are justifiable and auditable. It also supports compliance with data protection regulations by demonstrating due diligence in safeguarding sensitive information. An incorrect approach that bypasses a formal risk assessment and immediately applies a patch without understanding its full implications is professionally unacceptable. This could lead to unforeseen system instability, performance degradation, or even data corruption, all of which could have severe business and regulatory consequences. Such an action demonstrates a lack of due diligence and a failure to adhere to best practices in system administration and security management. Another incorrect approach, such as delaying any action until a full system outage is mandated, is also professionally unsound. This inaction allows the vulnerability to persist, increasing the risk of a security incident. It fails to meet the professional obligation to proactively manage and mitigate identified risks, potentially exposing the organization to significant financial and reputational damage, and could be seen as a violation of data protection responsibilities. Finally, an approach that focuses solely on the technical fix without considering the broader business impact or regulatory requirements is incomplete. While technical proficiency is essential, a DBA must also understand the business context and the legal framework governing the data they manage. This holistic view is crucial for making decisions that are not only technically sound, but also strategically aligned with organizational goals and legal obligations. The professional reasoning process for similar situations should involve 1. Clearly defining the problem and its potential impact. 2. Identifying all relevant stakeholders and their concerns. 3. Gathering information about potential solutions, including their risks and benefits. 4. Evaluating solutions against established policies, best practices, and regulatory requirements. 5. Selecting the most appropriate solution based on a comprehensive risk-benefit analysis. 6. Documenting the decision-making process and the chosen course of action. Question 4. Comparative studies suggest that when introducing a new, high-volume transactional application to an existing DB2 for Z/OS environment, a DBA faces a critical decision regarding performance optimization strategies. Which approach best balances the need for rapid application deployment with the imperative of maintaining system stability and data integrity? Option A. Rely exclusively on automated DB2 tuning utilities to identify and apply performance optimizations without manual intervention or in-depth analysis of the application's unique requirements. Option B. Conduct a thorough analysis of the new application's specific workload characteristics and implement targeted, incremental performance tuning adjustments with continuous monitoring and validation at each stage. Option C. Defer all performance tuning activities until after the application has been deployed and end users begin reporting significant performance issues, at which point emergency tuning measures will be applied. Option D. Implement a comprehensive suite of aggressive, system-wide performance tuning parameters immediately upon application deployment, based on general best practices for high-volume workloads. The correct answer is D. Implement a comprehensive suite of aggressive, system-wide performance tuning parameters immediately upon application deployment, based on general best practices for high-volume workloads. Explanation. Scenario analysis. This scenario presents a common challenge for DB2 for Z/OS DBAs, balancing performance optimization with the need for robust data integrity and adherence to operational best practices. The introduction of a new application with high transaction volumes necessitates careful consideration of how database changes will impact existing workloads and system stability. The pressure to deliver a functional application quickly can lead to shortcuts that compromise long-term maintainability and compliance. The DBA must navigate these competing demands, ensuring that performance gains do not introduce risks to data accuracy or violate established operational procedures. Correct approach analysis. The correct approach prioritizes a phased, controlled implementation of performance tuning strategies. This involves thorough analysis of the application's workload characteristics, including peak usage times, transaction types, and data access patterns. Implementing changes incrementally, such as adjusting buffer pool sizes, optimizing index structures, or implementing appropriate table partitioning, allows for continuous monitoring and validation. This aligns with best practices for system administration, which emphasize risk mitigation through systematic testing and validation. For DB2 for Z/OS, this also implies adherence to IBM's recommended tuning guidelines and the use of diagnostic tools to measure the impact of each change. The focus on understanding the why behind performance bottlenecks and addressing them with targeted, tested solutions ensures that the application performs optimally without introducing instability or data corruption. This methodical approach is crucial for maintaining the integrity of critical business data and ensuring compliance with internal operational policies and potentially external data governance standards, though specific external regulations are not detailed in this exam's scope. Incorrect approaches analysis. One incorrect approach involves immediately implementing aggressive, system-wide tuning parameters without understanding the specific application's needs or its interaction with other workloads. This is a failure of professional due diligence, risks destabilizing the entire DB2 subsystem, impacting other applications, and potentially leading to data corruption or extended downtime. This approach bypasses the critical step of analysis and testing, which is a cornerstone of responsible system administration. Another incorrect approach is to solely rely on automated tuning tools without expert human oversight and validation. While these tools can be helpful, they may not always account for the nuances of a specific environment or the business criticality of certain data. Over-reliance on automation without understanding the underlying principles can lead to suboptimal configurations or unintended consequences, failing to meet the professional standard of informed decision-making. A third incorrect approach is to defer all performance tuning until after the application is in production and issues are reported. This reactive stance is a significant professional failing. It prioritizes speed of deployment over system stability and data integrity, potentially leading to severe performance degradation, user dissatisfaction, and costly emergency fixes. It neglects the proactive responsibilities of a DBA to anticipate and mitigate potential problems. Professional reasoning. Professionals should adopt a structured, analytical approach to performance tuning. This involves 1. Understanding the requirements. Clearly define the application's performance goals and constraints. 2. Analyzing the workload. Use diagnostic tools to gather data on current performance and identify bottlenecks. 3. Developing a strategy. Create a plan for implementing changes, prioritizing those with the highest potential impact and lowest risk. 4. Implementing incrementally. Make changes one at a time, thoroughly testing and monitoring the impact of each. 5. Validating results. Confirm that performance improvements are achieved and that no negative side effects have been introduced. 6. Documenting changes. Maintain a record of all modifications and their outcomes for future reference and auditing. This systematic process ensures that decisions are data-driven, risks are managed, and the integrity of the database system is maintained. Question 5. Stakeholder feedback indicates a significant and ongoing degradation in the performance of critical DB2 for Z/OS applications, leading to user complaints and potential business disruption. As the lead DBA, what is the most appropriate and professionally responsible approach to address this issue? Option A. Apply a quick fix by disabling certain non-essential database features that are suspected of contributing to the slowdown, without a full understanding of their dependencies or impact on data integrity. Option B. Initiate a comprehensive performance analysis, including detailed logging and metric collection, to identify the root cause. Develop and test a targeted solution in a staging environment, documenting all steps and outcomes before applying it to production. Option C. Advise stakeholders that performance issues are often transient and suggest waiting for a period to see if the problem self-corrects before committing resources to an investigation. Option D. Immediately implement a series of aggressive DB2 parameter tuning adjustments across the entire subsystem, based on anecdotal evidence from similar past incidents, to quickly restore perceived performance. The correct answer is D. Immediately implement a series of aggressive DB2 parameter tuning adjustments across the entire subsystem, based on anecdotal evidence from similar past incidents, to quickly restore perceived performance. Explanation. Scenario analysis. This scenario presents a common challenge in database administration where performance degradation impacts critical business operations. The challenge lies in balancing the immediate need for resolution with the long-term implications of the chosen solution, particularly concerning data integrity and compliance with IBM DB2 DBA for Z/OS best practices and potential regulatory considerations for data handling and availability. The pressure to restore service quickly can lead to hasty decisions that might compromise security, auditability, or data consistency, all of which are paramount in a regulated environment. Correct approach analysis. The correct approach involves a systematic and documented investigation. This begins with gathering detailed performance metrics and error logs to pinpoint the root cause of the slowdown. Implementing a temporary workaround, if feasible and low risk, can provide immediate relief while a permanent fix is developed. Crucially, any changes made to the DB2 subsystem, such as parameter tuning or index modifications, must be thoroughly tested in a non-production environment that mirrors the production setup as closely as possible. This testing should include performance benchmarks and validation of data integrity. The entire process, including the problem identification, proposed solution, testing results, and implementation steps, must be meticulously documented. This documentation serves as an audit trail, demonstrating due diligence, adherence to best practices, and compliance with any relevant data governance policies. In the context of C2090-312, this aligns with the exam's focus on operational excellence, problem resolution, and maintaining a stable and reliable DB2 environment. Incorrect approaches analysis. Implementing a quick fix without thorough root cause analysis is a significant regulatory and ethical failure. It risks masking the underlying issue, leading to recurring problems and potential data corruption. This approach bypasses the due diligence required to ensure data integrity and system stability, which are fundamental to maintaining a trustworthy database. Applying a broad, system-wide parameter change without understanding its specific impact on the observed performance issue is also problematic. This can have unintended consequences, negatively affecting other applications or processes, and potentially violating performance SLAs or data availability requirements. It demonstrates a lack of analytical rigor and a failure to adhere to a controlled change management process. Ignoring the performance issue in the hope that it will resolve itself is a direct abdication of responsibility. This approach not only jeopardizes business operations, but also fails to meet the implicit and explicit obligations of a DBA to maintain system health and data accessibility. It can lead to significant financial losses and reputational damage, and in regulated industries, could result in noncompliance with data availability and integrity mandates. Professional reasoning. Professionals should adopt a structured problem-solving methodology. This involves 1. Clearly defining the problem and its impact. 2. Gathering comprehensive data and performing root cause analysis. 3. Evaluating potential solutions, considering their risks, benefits, and impact on data integrity and compliance. 4. Developing and testing the chosen solution in a controlled environment. 5. Implementing the solution with a rollback plan. 6. Documenting all steps and outcomes. This systematic approach ensures that decisions are informed, risks are mitigated, and the integrity and availability of the data are preserved, aligning with professional ethics and regulatory expectations. Question 6. To address the challenge of optimizing DB211 for Z/OS performance in a critical production environment, which approach best balances the need for rapid improvement with the imperative of maintaining data integrity and system stability? Option A. Apply a tuning technique that has been successful in a different, albeit similar, DB2 environment without specific validation for the current production workload. Option B. Conduct thorough analysis of the workload, develop targeted tuning strategies, rigorously test these strategies in a representative non-production environment, and then implement them in production with a defined rollback plan. Option C. Directly implement the proposed tuning changes in the production environment after a brief review of the most recent performance metrics to achieve immediate gains. Option D. Focus solely on optimizing the specific SQL statements identified as slow, without considering their impact on other queries or the overall system resource utilization. The correct answer is C. Directly implement the proposed tuning changes in the production environment after a brief review of the most recent performance metrics to achieve immediate gains. Explanation. Scenario analysis. This scenario presents a common challenge for DB211 for Z/OS DBAs, balancing performance optimization with the need for robust data integrity and adherence to established operational procedures. Pressure to deliver rapid performance improvements, especially in a production environment, can lead to hasty decisions that bypass critical validation steps. The professional challenge lies in resisting immediate gratification for a potentially quick fix, and instead prioritizing a methodical, risk-averse approach that safeguards the stability and reliability of the database. The complexity of Z/OS and DB2 environments, with their intricate interdependency, amplifies the potential impact of ill-considered changes. Correct approach analysis. The correct approach emphasizes a phased, controlled implementation of performance tuning strategies. This involves thorough analysis of the existing workload, identification of specific bottlenecks, and the development of targeted solutions. Crucially, it mandates comprehensive testing in a non-production environment that closely mirrors production. This testing phase allows for the evaluation of the proposed changes' impact on performance, resource utilization, and most importantly, data integrity. The subsequent controlled rollout to production, often with a rollback plan, minimizes risk. This methodology aligns with best practices for IT change management, which are implicitly supported by regulatory frameworks emphasizing system availability, data accuracy, and operational resilience. In the context of DB2 for Z/OS, this approach ensures that performance enhancements do not inadvertently introduce data corruption or system instability, which could have significant business and compliance implications. Incorrect approaches analysis. Implementing performance tuning changes directly in the production environment without prior testing is a significant regulatory and ethical failure. It violates the principle of least privilege and due diligence, as it exposes critical data and systems to unverified modifications. This bypasses established change control procedures, which are designed to prevent unintended consequences and ensure auditability. Such an approach risks data corruption, system downtime, and potential non-compliance with data integrity regulations. Applying a performance tuning technique based solely on anecdotal evidence or a single, isolated performance metric, without understanding the broader workload context, is also professionally unacceptable. This can lead to suboptimal or even detrimental changes. It demonstrates a lack of analytical rigor and a failure to adhere to a systematic problem-solving methodology. This can result in wasted resources, continued performance issues, or the introduction of new problems, potentially impacting business operations and trust. Ignoring the potential impact of performance tuning on other applications or system components that share the DB2 subsystem is another critical failure. DB2 on Z/OS often supports multiple critical applications. A change optimized for one workload might negatively affect another, leading to widespread performance degradation or functional issues. This demonstrates a lack of holistic system understanding and a failure to consider the broader operational impact, which is a cornerstone of responsible system administration and can have regulatory implications related to service-level agreements and business continuity. Professional reasoning. Professionals should adopt a structured approach to performance tuning. This involves 1. Understanding the business context. What are the performance goals and their business impact? 2. Workload analysis. Deeply understand the current and expected database workload. 3. Hypothesis generation. Formulate specific, testable hypotheses about performance bottlenecks and potential solutions. 4. Controlled testing. Rigorously test proposed solutions in a representative non-production environment. 5. Impact assessment. Evaluate performance, resource usage, and data integrity. 6. Phased rollout. Implement changes incrementally in production with robust monitoring and rollback capabilities. 7. Continuous monitoring. Regularly review performance and system health post-implementation. This systematic process ensures that changes are beneficial, safe, and auditable, aligning with professional ethics and regulatory expectations for data management and system stability. Question 7. The assessment process reveals that a critical DB2 for Z/OS maintenance task requires a planned outage. The DBA team is evaluating different strategies to ensure minimal data loss and rapid recovery in case the maintenance introduces unexpected issues. Which approach best aligns with professional best practices and regulatory expectations for data integrity and availability? Option A. Implement a comprehensive rollback plan that has been thoroughly tested in a pre-production environment, allowing for a swift return to the previous stable state if the maintenance is unsuccessful. Option B. Perform the maintenance without a documented rollback strategy, assuming the likelihood of failure is low and that any issues can be addressed on the fly. Option C. Proceed with the maintenance and rely on manual data recovery procedures if any problems arise, assuming the DBA team's expertise can quickly resolve any data inconsistencies. Option D. Attempt to perform the maintenance while the system is still online, hoping to minimize the outage duration and address any potential data conflicts as they occur. Correct answer is A. Implement a comprehensive rollback plan that has been thoroughly tested in a pre-production environment, allowing for a swift return to the previous stable state if the maintenance is unsuccessful. Explanation. The assessment process reveals a common challenge in DB2 for Z/OS environments, ensuring data integrity and availability during critical maintenance windows. The scenario is professionally challenging because it requires balancing the need for system updates with the imperative to minimize disruption to business operations. A DBA must possess a deep understanding of DB2 recovery and restart capabilities, as well as the potential impact of various maintenance strategies on ongoing transactions and data consistency. Careful judgment is required to select a strategy that is both effective for the maintenance task and compliant with internal policies and potentially external regulatory requirements for data availability and auditability. The correct approach represents best professional practice because it prioritizes a controlled and documented rollback strategy. This aligns with the principle of least privilege and defense in depth, ensuring that if the maintenance fails or introduces unforeseen issues, the system can be rapidly restored to a known good state without data loss. This proactive approach minimizes business impact and demonstrates due diligence in system management. From a regulatory perspective, maintaining data integrity and availability is often a core requirement, and a well-defined rollback plan directly supports these objectives by providing a mechanism for rapid recovery. An incorrect approach that involves proceeding with the maintenance without a validated rollback plan is a significant regulatory and ethical failure. It violates the principle of responsible system administration by introducing unnecessary risk. If the maintenance fails, the inability to quickly restore the system could lead to extended downtime, directly impacting business operations and potentially violating service-level agreements or regulatory mandates for data availability. Furthermore, proceeding without a rollback plan suggests a lack of foresight and adherence to established best practices for change management, which are often implicitly or explicitly required by IT governance frameworks. Another incorrect approach, such as attempting to manually recover data after a failed maintenance, is also professionally unacceptable. This is highly prone to human error, can be time-consuming, and may not guarantee complete data consistency. It represents a failure to leverage the robust recovery mechanisms provided by DB2 and a disregard for established, tested procedures. This approach could lead to data corruption or loss, which has severe regulatory implications, especially in industries with strict data retention and integrity requirements. It also demonstrates a lack of understanding of the fundamental principles of database administration and disaster recovery. The professional decision-making process for similar situations should involve a thorough risk assessment of any proposed change. This includes evaluating the potential impact of the change, identifying rollback strategies, and testing those strategies in a non-production environment. Adherence to established change management procedures, including proper documentation and approval workflows, is crucial. Professionals should always prioritize solutions that minimize risk, ensure data integrity, and maintain system availability, aligning with both internal policies and relevant regulatory guidelines. Question 8. Quality control measures reveal that a critical DB211 for Z/OS system update requires immediate application to address a security vulnerability. The update has been tested in a development environment, but not in a staging or pre-production environment that closely mirrors production. The maintenance window is limited, and the business has expressed strong concerns about any extended downtime. Which of the following approaches best balances the need for security, data integrity, and minimal business disruption, while adhering to professional best practices for DB211 for Z/OS administration? Option A. Delay the update until a comprehensive staging environment test can be completed, even if it means extending the vulnerability exposure period, and then schedule a full production deployment during a less critical period. Option B. Implement the update in a phased manner, starting with a small subset of non-critical production systems, followed by immediate verification, and then a gradual rollout to the remaining production systems, with a robust rollback strategy in place for each phase. Option C. Proceed with the update directly to all production systems within the allocated maintenance window, relying on the development environment testing and a predefined rollback plan if issues arise. Option D. Apply the update to a single, isolated production system first, verify its functionality thoroughly, and then proceed with the remaining systems, accepting a slightly longer overall deployment time. The correct answer is C. Proceed with the update directly to all production systems within the allocated maintenance window, relying on the development environment testing and a predefined rollback plan if issues arise. Explanation. Scenario analysis. This scenario presents a common challenge for DB2 for Z/OS DBAs, ensuring data integrity and availability during critical system maintenance. The challenge lies in balancing the need for essential updates with the imperative to minimize disruption to business operations. A poorly executed maintenance window can lead to extended downtime, data corruption, performance degradation, and significant financial losses, all of which can have severe regulatory and compliance implications. The pressure to complete tasks quickly, while adhering to strict change control and rollback procedures, requires meticulous planning and execution. Correct approach analysis. The correct approach emphasizes a phased, controlled deployment with robust validation and rollback capabilities. This aligns with best practices for IT service management and regulatory compliance, particularly those related to data integrity and business continuity. By performing a pilot deployment in a non-production environment, the DBA can identify and resolve potential issues without impacting live users. The subsequent staged rollout to production, coupled with immediate post-implementation verification and a predefined rollback plan, minimizes risk. This methodology ensures that any unforeseen problems can be addressed swiftly, restoring the system to its previous stable state, thereby upholding data integrity and service availability, as mandated by general IT governance principles and potentially specific industry regulations concerning data protection and operational resilience. Incorrect approaches analysis. Implementing the update directly to all production systems without prior testing in a non-production environment is a significant regulatory and ethical failure. This bypasses essential quality assurance steps, increasing the risk of introducing critical errors into the live system. Such an approach violates principles of due diligence and prudent system management, potentially leading to data loss or corruption, which could have severe compliance consequences depending on the data's nature and applicable regulations. Performing the update during peak business hours, even with a rollback plan, is also professionally unacceptable. This directly jeopardizes business operations and service availability, which is a core responsibility of a DBA. While a rollback plan exists, the immediate impact of an error during peak times can be catastrophic, leading to financial losses and reputational damage. This demonstrates a lack of consideration for business continuity and service-level agreements, which are often implicitly or explicitly governed by regulatory expectations. Skipping the verification steps after the update, even if the deployment appears successful, is another critical failure. Post-implementation verification is crucial to confirm that the update has been applied correctly and that all dependent applications are functioning as expected. Omitting this step leaves the system vulnerable to latent issues that may surface later, potentially causing unexpected downtime or data inconsistencies. This negligence can be seen as a failure to maintain system integrity and can have serious compliance ramifications if data accuracy or availability is compromised. Professional reasoning. Professionals should adopt a risk-based approach to system maintenance. This involves a thorough assessment of potential impacts, the development of detailed plans that include testing, phased deployment, verification, and rollback strategies. Change management processes, which are often mandated by regulatory frameworks, must be strictly followed. The decision-making process should prioritize data integrity, system availability, and minimal business disruption. When faced with a critical update, the DBA must advocate for sufficient time and resources to execute these best practices, even if it means delaying the deployment to ensure a successful and compliant outcome. Question 9. Governance review demonstrates that a critical DB2 for Z/OS application is experiencing performance degradation. The DBA team has identified a potential tuning parameter change that, in preliminary testing, significantly improves response times. However, the proposed change has not undergone a formal security impact assessment or a comprehensive review against relevant U.S. data protection regulations. What is the most appropriate course of action for the DBA to ensure both performance improvement and regulatory compliance? Option A. Apply the tuning parameter change to a subset of the production environment to monitor its impact, assuming that a partial rollout will mitigate risks and allow for quicker validation. Option B. Document the performance improvement in a report and recommend the change, deferring the security and compliance review to a later date when resources are more readily available. Option C. Implement the tuning parameter change immediately in the production environment, as the performance gains are critical for business operations, and address any potential compliance issues post-implementation. Option D. Proceed with a full security and compliance review of the proposed tuning parameter change in a dedicated, isolated test environment that mirrors production, and only implement the change after formal approval through the established change management process. The correct answer is C. Implement the tuning parameter change immediately in the production environment, as the performance gains are critical for business operations, and address any potential compliance issues post-implementation. Explanation. Scenario analysis. This scenario presents a common challenge in database administration where performance tuning efforts, while seemingly beneficial, can inadvertently introduce security vulnerabilities or compliance risks. The challenge lies in balancing the immediate need for improved application response times with the long-term imperative of maintaining data integrity, security, and adherence to regulatory mandates. A DBA must possess a deep understanding of both DB2 for Z/OS internals and the relevant governance frameworks to make informed decisions that do not compromise the organization's risk posture. The pressure to deliver performance improvements quickly can lead to shortcuts that bypass established change control and security validation processes, creating a significant professional risk. Correct approach analysis. The correct approach involves a comprehensive, risk-based evaluation that prioritizes security and compliance alongside performance. This aligns with best practices for IT governance and data management, which mandate that all system changes undergo a thorough impact assessment. Specifically, for a regulated environment like that governed by U.S. financial regulations, assuming this context for C2090-312, as Z/OS is prevalent in such sectors, changes impacting database performance must be scrutinized for their effect on data security controls, audit trails, and the integrity of financial data. Implementing a change only after rigorous testing in a non-production environment, including security vulnerability scans and compliance checks against relevant U.S. regulations e.g. SOX, PCI DSS if applicable, and obtaining formal approval through a documented change management process is the only professionally responsible and compliant course of action. This methodical approach ensures that performance gains do not come at the cost of regulatory noncompliance or security breaches, which could lead to severe financial penalties and reputational damage. Incorrect approach is analysis. Implementing the performance tuning change without a thorough security and compliance review is a direct violation of IT governance principles and likely contravenes specific U.S. regulatory requirements for data protection and integrity. This approach prioritizes immediate operational needs over systemic risk management, creating a significant ethical and professional failure. Bypasses essential control mechanisms designed to prevent unauthorized access, data modification, or disclosure, which are critical under regulations like SOX. Applying the performance tuning change based solely on positive results in a limited, isolated test environment, without considering its broader impact on production security configurations or existing compliance controls, is also professionally unacceptable. A test environment, however well configured, may not fully replicate the complex security interdependencies and audit logging requirements of a production Z/OS system. This oversight can lead to unforeseen vulnerabilities in the live environment, exposing sensitive data and violating compliance mandates. Deploying the performance tuning change without formal change management approval, even if security and compliance were considered, represents a failure in operational discipline and governance. Formal change control processes are in place to ensure that all modifications are documented, reviewed, and authorized, providing an audit trail and a mechanism for rollback if issues arise. Bypassing this process introduces an unacceptable level of risk and undermines the organization's ability to demonstrate control over its IT environment, a key requirement for many U.S. regulatory frameworks. Professional reasoning. Professionals in this role must adopt a risk-aware mindset. The decision-making process should begin with identifying potential impacts of any proposed change, not just on performance, but critically on security, compliance, and data integrity. This involves consulting relevant internal policies, external regulations, and security best practices. A structured approach, incorporating a change advisory board, CAB, or similar governance body, formal risk assessments and comprehensive testing, including security and compliance validation, is essential. When faced with pressure to expedite changes, professionals must advocate for adherence to established processes, clearly articulating the risks associated with shortcuts. The ultimate responsibility lies in safeguarding the organization's data and ensuring its operations remain compliant and secure, even if it means delaying a performance enhancement until all due diligence is completed. Question 10. Consider a scenario where a critical production DB2 for Z/OS subsystem is experiencing significant transaction slowdowns, impacting end-user productivity. The pressure is mounting to implement immediate performance improvements. A junior DBA proposes applying a comprehensive set of performance tuning parameters and index recommendations across all high-volume tables, based on a recent industry white paper, without conducting detailed workload analysis or testing in a development or staging environment. As the lead DBA, what is the most professionally responsible course of action to ensure both performance gains and data integrity? Option A. Instruct the junior DBA to revert all recent configuration changes and focus solely on routine maintenance tasks until a formal performance tuning project is approved and resourced. Option B. Inform management that performance issues are inherent to the current system architecture and cannot be resolved without a major upgrade, thus deferring any immediate tuning efforts. Option C. Conduct a thorough analysis of the current workload using DB2 performance monitoring tools, prototype the proposed changes in a non-production environment, and develop a phased rollout plan with rollback procedures before applying any changes to production. Option D. Immediately implement the proposed tuning parameters and index recommendations across all critical tables to address the urgent performance issues, as the white paper is a reputable source. The correct answer is D. Immediately implement the proposed tuning parameters and index recommendations across all critical tables to address the urgent performance issues, as the white paper is a reputable source. Explanation. Scenario analysis. This scenario presents a common challenge for DB2 for Z/OS DBAs, balancing performance optimization with the integrity and recoverability of critical production data. The pressure to deliver rapid performance improvements, especially in a high-transaction environment, can lead to hasty decisions that overlook potential risks. The professional challenge lies in rigorously evaluating proposed solutions against established best practices and regulatory compliance, rather than succumbing to immediate, potentially superficial, gains. The need for deep understanding of DB2 internals, workload characteristics, and the implications of configuration changes is paramount. Correct approach analysis. The correct approach involves a phased, controlled implementation of performance tuning measures, prioritizing thorough testing and validation. This aligns with best practices for production system management, emphasizing risk mitigation and data integrity. Specifically, for DB2 on Z/OS, this means 1. Understanding the workload, analyzing the specific SQL statements, access paths, and transaction patterns that are causing performance bottlenecks. This is crucial for targeted tuning. 2. Utilizing DB2 tools, employing diagnostic tools like the DB2 Performance Monitor (PM), Instrumentation Facility Interface (IFI), and Query Monitor to gather detailed performance metrics. 3. Prototyping and testing, implementing proposed changes, e.g., index creation, statistics updates, buffer pool adjustments in a non-production environment that closely mirrors production. This allows for performance measurement and validation without impacting live data. 4. Gradual rollout. For critical changes, a phased rollout in production, e.g., during off-peak hours to a subset of users, with robust monitoring and rollback plans is essential. 5. Documentation and review. Maintaining detailed records of all changes, their rationale, and their impact, and conducting post-implementation reviews. This methodical approach ensures that performance improvements are sustainable, do not introduce new issues, and maintain compliance with data governance and audit requirements. Incorrect approach is analysis. Implementing a broad set of unproven tuning parameters across all critical tables without prior analysis or testing is a significant regulatory and ethical failure. It violates the principle of due diligence in system administration. Applying a one-size-fits-all tuning strategy without understanding the specific workload characteristics of the application is a direct contravention of best practices for performance management. This can lead to unintended consequences, such as increased I/O lock contention, or even data corruption, jeopardizing data integrity and availability. Making direct changes to production system parameters, or DDL, without a documented change management process, peer review, or a rollback strategy is a critical failure. This bypasses established controls designed to prevent accidental data loss or system downtime. Such actions can lead to audit findings related to inadequate change control and risk management. Prioritizing speed of implementation over thorough testing and validation demonstrates a disregard for data integrity and system stability. This can result in performance degradation, increased operational costs, and potential data loss, which are all unacceptable from a regulatory and ethical standpoint, particularly concerning data protection and business continuity. Professional reasoning. Professionals should adopt a risk-based, data-driven approach to performance tuning. This involves 1. Problem identification. Clearly define the performance issue with quantifiable metrics. 2. Root cause analysis. Utilize diagnostic tools to understand the underlying causes. 3. Solution design. Propose targeted solutions based on the analysis. 4. Impact assessment. Evaluate potential risks and benefits of each solution. 5. Testing and validation. Rigorously test solutions in a representative environment. 6. Controlled implementation. Deploy changes using a formal change management process with rollback capabilities. 7. Monitoring and review. Continuously monitor performance and review the effectiveness of changes. This structured decision-making process ensures that performance tuning is conducted responsibly, minimizing risk to data integrity and system availability, and adhering to professional standards and regulatory expectations. Question 11. The investigation demonstrates that a critical DB2 for Z/OS environment is being considered for an upgrade to incorporate advanced indexing techniques to improve query performance. The DBA team has identified several potential indexing strategies, but the impact on data integrity and application availability during and after implementation is a primary concern. Given the system's role in processing sensitive financial transactions, which of the following implementation approaches best aligns with professional best practices and regulatory expectations for maintaining data integrity and system stability? Option A. Implement the chosen advanced indexing strategy directly into the production environment during a scheduled maintenance window, relying on the vendor's documentation for configuration guidance and assuming minimal impact due to the nature of indexing. Option B. Deploy the new indexing strategy to a limited set of non-critical applications first, and if no immediate issues are observed, proceed with a full production rollout without extensive regression testing on the core financial transaction applications. Option C. Conduct a comprehensive impact analysis. Develop a detailed implementation plan including thorough testing in a representative non-production environment, and establish a robust rollback strategy before proceeding with the production deployment. Option D. Prioritize the immediate deployment of the new indexing strategy to production to realize performance gains as quickly as possible, addressing any potential issues reactively as they arise during peak operational hours. The correct answer is A. Implement the chosen advanced indexing strategy directly into the production environment during a scheduled maintenance window, relying on the vendor's documentation for configuration guidance and assuming minimal impact due to the nature of indexing. Explanation. The investigation demonstrates a common but critical challenge in DB2 for Z/OS environments, ensuring data integrity and availability during a complex system upgrade, specifically when dealing with the implementation of new indexing strategies. The professional challenge lies in balancing the need for performance improvements offered by advanced indexing techniques against the inherent risks of data corruption, application downtime, and potential regulatory noncompliance if not executed flawlessly. The Z/OS environment, with its stringent uptime requirements and the critical nature of the data it manages, amplifies these risks. The correct approach represents best professional practice because it prioritizes a phased, controlled, and thoroughly tested implementation. This involves meticulous planning, including impact analysis on existing applications and workloads, comprehensive testing in a non-production environment that mirrors production as closely as possible, and a well-defined rollback strategy. This methodical approach minimizes the risk of unforeseen issues, ensures that the new indexing strategy meets performance objectives without negatively impacting data integrity, and crucially, adheres to the implicit regulatory expectation of maintaining operational stability and data accuracy. In a regulated industry, demonstrating due diligence through such rigorous testing and planning is paramount. An incorrect approach that involves immediately deploying the new indexing strategy to production without adequate testing or a rollback plan represents a significant regulatory and ethical failure. This demonstrates a disregard for the principle of least privilege and a failure to uphold the duty of care to protect data and ensure system availability. From a regulatory standpoint, this could lead to data breaches, service disruptions, and failure to meet service level agreements, SLAs, potentially incurring severe penalties. Ethically, it shows a lack of professional responsibility and a failure to safeguard the organization's assets and reputation. Another incorrect approach, such as relying solely on vendor documentation without independent validation or internal testing, also poses regulatory and ethical risks. While vendor documentation is a valuable resource, it cannot account for the unique configurations, workloads, and interdependencies present in a specific production environment. Failure to validate these recommendations internally can lead to unexpected performance degradation or data integrity issues, again violating the duty of care and potentially leading to regulatory scrutiny. A third incorrect approach, which might involve implementing the new indexing strategy during peak production hours to minimize perceived downtime, is also professionally unsound. This significantly increases the risk of impacting critical business operations and data transactions. The potential for widespread disruption and data corruption during a live, high-demand period is immense, representing a failure to manage risk effectively and a disregard for business continuity, which are often subject to regulatory oversight. The professional decision-making process for similar situations should involve a risk-based assessment. This includes identifying potential impacts, evaluating the likelihood and severity of those impacts, and implementing controls to mitigate them. For database changes, this translates to thorough impact analysis, robust testing methodologies, unit, integration, performance, and regression testing, comprehensive documentation of changes, clear communication with stakeholders, and a well-rehearsed rollback plan. Adherence to established change management processes and seeking peer review are also critical components of professional decision-making in such high-stakes environments. Question 12. Upon reviewing the performance metrics for a critical DB2 for Z/OS database, it has been identified that a specific index is causing significant performance degradation during peak transaction periods. The proposed solution is to rebuild this index, considering the absolute priority of maintaining application availability and data integrity. Which of the following implementation strategies best adheres to professional best practices and regulatory expectations for production Z/OS environment? Option A. Perform the index rebuild during the busiest transaction period to gather immediate performance feedback and identify any issues quickly. Option B. Conduct a comprehensive index rebuild in a development environment that closely mirrors the production configuration, followed by thorough application testing and a documented, tested rollback plan before scheduling the change for a low-impact period in production. Option C. Execute the index rebuild directly in the production environment during the next scheduled maintenance window, assuming the maintenance window is sufficient. Option D. Initiate the index rebuild in production immediately, as the performance issue is critical and requires urgent resolution, without a predefined rollback strategy. The correct answer is C. Execute the index rebuild directly in the production environment during the next scheduled maintenance window, assuming the maintenance window is sufficient. Explanation. Scenario analysis. This scenario presents a common yet critical implementation challenge for a DB2 DBA for Z/OS. Managing the impact of a critical database object change on application availability and data integrity. The challenge lies in balancing the need for system maintenance and performance improvement with the absolute requirement to minimize downtime and prevent data corruption. The DBA must navigate potential conflicts between development, testing, and production environments, ensuring that changes are thoroughly validated before deployment. The pressure to deliver a solution quickly, coupled with the inherent complexity of Z/OS and DB2 environments, necessitates a methodical and risk-aware approach. Correct approach analysis. The correct approach involves a phased implementation strategy that prioritizes thorough testing and validation in non-production environments before introducing the change to production. This includes performing the index rebuild in a development or test environment that closely mirrors the production configuration, followed by rigorous application testing to confirm functionality and performance. A rollback plan must be meticulously documented and tested. The change should then be scheduled during a planned maintenance window with minimal user impact, and the implementation should be closely monitored. This approach represents best professional practice because it adheres to the principle of least privilege and risk mitigation. It ensures that potential issues are identified and resolved before they affect live operations, thereby safeguarding data integrity and application availability, which are paramount in regulated environments. This aligns with general IT best practices for change management and disaster recovery, emphasizing proactive problem-solving over reactive crisis management. Incorrect approaches analysis. Implementing the index rebuild directly in the production environment without prior testing in a representative environment is a significant regulatory and ethical failure. It violates the principle of due diligence and introduces an unacceptable level of risk to data integrity and application availability. Such an approach could lead to unexpected performance degradation, application failures, or even data corruption, potentially resulting in non-compliance with service-level agreements, SLAs, and regulatory mandates that require continuous availability and data accuracy. Performing the index rebuild during peak business hours without proper communication or a tested rollback plan is also professionally unacceptable. This demonstrates a disregard for business continuity and user impact. It can lead to significant financial losses due to downtime and reputational damage. Ethically, it shows a lack of consideration for stakeholders who rely on the application's availability. Failing to document or test a rollback strategy before attempting the production change is a critical oversight. This leaves the DBA without a clear and tested path to revert to a stable state if the implementation encounters unforeseen problems. This directly contravenes best practices for change management and disaster recovery planning, increasing the likelihood of prolonged outages and data loss in the event of an issue. Professional reasoning. Professionals in this role must adopt a risk-based decision-making framework. This involves a thorough assessment of the potential impact of any change on system availability, data integrity, and application functionality. The process should always begin with understanding the business criticality of the affected system and the potential consequences of failure. A structured change management process, including impact analysis, risk assessment, detailed planning, rigorous testing in representative environments, and a well-defined rollback strategy, is essential. Communication with all relevant stakeholders, including application owners, end users, and management, is crucial throughout the process. The ultimate goal is to implement changes that enhance system performance and stability while minimizing disruption and risk. Question 13. System analysis indicates that a critical application, heavily reliant on a DB2 for Z/OS database, is scheduled for a major version upgrade. The application team has provided the new version and a general timeline, but has not specified detailed testing or deployment procedures. As the DB2 DBA for Z/OS, what is the most prudent approach to ensure a successful and minimally disruptive upgrade? Option A. Immediately schedule the upgrade for the production environment during a low-activity window, focusing on post-upgrade performance monitoring and tuning. Option B. Inform the application team that DB2 for Z/OS does not support such upgrades and recommend they revert to the previous application version. Option C. Proceed with the upgrade in the production environment without extensive pre-testing, relying on the application team's assurance of compatibility. Option D. Develop a comprehensive testing plan in a representative non-production environment. Create a detailed rollback strategy and consider a phased rollout approach. The correct answer is A. Immediately schedule the upgrade for the production environment during a low-activity window, focusing on post-upgrade performance monitoring and tuning. Explanation. Scenario analysis. This scenario presents a common yet critical challenge for a DB2 DBA for Z/OS. managing the impact of a planned application upgrade on database performance and availability. The challenge lies in balancing the need for timely application deployment with the imperative to ensure minimal disruption to business operations. A misstep can lead to significant financial losses, reputational damage, and potential regulatory noncompliance if service-level agreements, SLAs, are breached. The DBA must not only understand the technical implications, but also the business context and the criticality of the affected data. Correct approach analysis. The correct approach involves a comprehensive, multi-phase strategy that prioritizes risk mitigation and validation. This begins with thorough pre-upgrade testing in a representative non-production environment. This testing must simulate realistic workloads and data volumes to identify potential performance bottlenecks or compatibility issues introduced by the new application version. Following successful testing, a detailed rollback plan is essential. This plan should outline the precise steps to revert to the previous stable state if the upgrade encounters unforeseen problems, minimizing downtime. Finally, a phased rollout, potentially starting with a subset of users or a less critical environment, allows for real-time monitoring and early detection of issues before a full production deployment. This methodical approach aligns with best practices for change management and operational stability, ensuring that the upgrade process is controlled, predictable, and minimizes business risk. Incorrect approaches analysis. Implementing the upgrade directly in the production environment without prior testing is a severe regulatory and ethical failure. It demonstrates a disregard for operational stability and business continuity, potentially violating contractual obligations, SLAs, and leading to data corruption or service unavailability. This approach is professionally unacceptable as it prioritizes speed over safety and due diligence. Performing extensive performance tuning on the production system after the upgrade has been deployed without a pre-upgrade assessment is also a failure. While performance tuning is a DBA responsibility, doing it reactively in a live production environment post-upgrade introduces significant risk. It suggests a lack of foresight and proactive planning, potentially leading to prolonged performance degradation and user dissatisfaction. This reactive stance can also lead to breaches of SLAs and erode customer trust. Skipping the creation of a detailed rollback plan, even with successful pre-upgrade testing, is a critical oversight. While testing aims to prevent issues, it cannot guarantee their complete absence. Without a robust rollback plan, a minor unforeseen problem can escalate into a major outage, causing significant business disruption and potential financial losses. This lack of preparedness is a failure in risk management and operational readiness. Professional reasoning. Professionals in this role must adopt a proactive and risk-aware mindset. Decision-making process should always begin with understanding the business impact of the proposed change. This involves consulting with application owners and business stakeholders to ascertain the criticality of the application and its associated data. The next step is to leverage available tools and methodologies for comprehensive testing in environments that closely mirror production. This includes performance testing, functional testing, and integration testing. Concurrently, a detailed change management plan, including a comprehensive rollback strategy, must be developed and reviewed. Communication is paramount throughout the process, ensuring all stakeholders are informed of the plan, potential risks, and progress. This structured approach, grounded in risk assessment and mitigation, is the hallmark of professional DBA practice. Question 14. Examination of the data shows a significant increase in transaction response times for a critical financial application running on DB2 for Z/OS. Users are reporting delays, and the application service level agreement, SLA, is at risk of being breached. The system administrator has observed a slight uptick in overall CPU utilization on the Z/OS LPAR, but no specific DB2 subsystem resource bottlenecks are immediately apparent through basic monitoring. What is the most appropriate initial course of action for the DB2 DBA to take to diagnose and resolve this performance degradation? Option A. Focus solely on tuning the Z/OS operating system parameters, such as page dataset allocation and dispatching priorities, as the CPU utilization has shown a slight increase. Option B. Immediately increase the size of the DB2 buffer pools and log buffers, assuming that increased resource allocation will alleviate the performance bottleneck, and then monitor the system. Option C. Initiate a comprehensive analysis of the application's SQL statements using DB2 Explain Facility, correlating the findings with DB2 accounting and statistics traces to identify inefficient queries or access paths that may be contributing to the increased response times. Simultaneously, review relevant DB2 configuration parameters and recent system changes. Option D. Roll back the most recent application code deployment, as it is the most likely culprit for performance issues, and await further investigation. The correct answer is C. Initiate a comprehensive analysis of the application's SQL statements using DB2 Explain Facility, correlating the findings with DB2 accounting and statistics traces to identify inefficient queries or access paths that may be contributing to the increased response times. Simultaneously, review relevant DB2 configuration parameters and recent system changes. Explanation. Scenario analysis. This scenario presents a common challenge in DB2 for Z/OS environments where performance degradation impacts critical business operations. The challenge lies in accurately diagnosing the root cause of the performance issue, which could stem from various factors including inefficient SQL, suboptimal DB2 configuration, or underlying system resource contention. A DBA must balance the urgency of resolving the performance issue with the need to avoid introducing further instability or violating operational procedures. The risk of misdiagnosis can lead to wasted effort, prolonged downtime, and potential financial or reputational damage. Correct approach analysis. The correct approach involves a systematic and data-driven investigation. This includes leveraging DB2 diagnostic tools like the Explain Facility to analyze query execution plans, monitoring DB2 performance metrics e.g. buffer pool hit ratios, lock weights, CPU usage, and examining system logs for any related errors or warnings. This methodical process ensures that the identified solution directly addresses the root cause, minimizing the risk of unintended consequences. Adhering to established change management procedures, including thorough testing in a non-production environment and obtaining necessary approvals, is paramount to maintaining system stability and compliance with operational governance. This aligns with best practices for IT service management and risk mitigation. Incorrect approaches analysis. One incorrect approach would be to immediately implement a broad, untested change, such as increasing buffer pool sizes, without understanding the current utilization or identifying specific queries that would benefit. This could lead to increased memory consumption without a proportional performance gain, or even negatively impact other workloads. It bypasses the diagnostic phase and risks introducing new problems, violating the principle of least change and potentially contravening internal IT policies that mandate impact analysis and testing. Another incorrect approach would be to focus solely on SQL tuning, without considering the broader DB2 and Z/OS environment. While inefficient SQL is a common cause of performance issues, ignoring system-level metrics or potential locking contention could lead to an incomplete or ineffective solution. This approach fails to consider the interconnectedness of the DB2 subsystem and its operating environment, which is a critical aspect of Z/OS administration. A third incorrect approach would be to revert to a previous, known good configuration without proper analysis. While this might offer a temporary fix, it doesn't address the underlying cause of the new performance issue. This reactive approach can mask deeper problems and prevent proactive problem solving, potentially leading to recurring issues and a lack of continuous improvement. It also fails to document the investigation and resolution, hindering future troubleshooting efforts. Professional reasoning. Professionals should adopt a structured problem-solving methodology. This typically involves 1. Problem identification and scoping. Clearly define the observed issue and its impact. 2. Data gathering and analysis. Collect relevant diagnostic data from DB2 and the Z/OS system. 3. Hypothesis generation. Formulate potential causes based on the data. 4. Solution design and testing. Develop and test potential solutions in a controlled environment. 5. Implementation and verification. Deploy the tested solution and monitor its effectiveness. 6. Documentation and review. Record the process, solution, and outcomes for future reference and continuous improvement. This systematic approach ensures that decisions are informed, risks are managed, and solutions are effective and sustainable. Question 15. Performance analysis shows that a critical applications reporting query is experiencing significant slowdowns, impacting end-of-day processing. The query accesses several large tables, and the current execution plan indicates a full table scan on one of the key tables. As the DB2 for Z/OS DBA, what is the most prudent course of action to address this performance degradation? Option A. Immediately create the proposed index directly in the production environment to resolve the end-of-day processing issue as quickly as possible. Option B. Create a new index on the column S, identified as the filtering criteria in the problematic query. Test its impact on performance and resource utilization in a development environment that closely mirrors production, and if successful, schedule the change for implementation during a maintenance window with a rollback plan. Option C. Apply a generic set of DB2 performance tuning parameters across the entire subsystem, assuming this will broadly improve query performance. Option D. Inform the application development team that the query is inherently inefficient and requires a complete rewrite, without investigating potential database-level optimizations. The correct answer is B. Create a new index on the column S, identified as the filtering criteria in the problematic query. Test its impact on performance and resource utilization in a development environment that closely mirrors production, and if successful, schedule the change for implementation during a maintenance window with a rollback plan. Explanation. Scenario analysis. This scenario presents a common challenge for DB2 for Z/OS DBAs, optimizing query performance without negatively impacting the stability and availability of critical production systems. The challenge lies in balancing the need for rapid query execution with the potential risks associated with making significant changes to the database environment. Unforeseen consequences of tuning actions can lead to performance degradation, increased resource consumption, or even system outages, all of which have direct financial and reputational implications for the organization. The DBA must possess a deep understanding of DB2 internal mechanisms, the application's workload, and the underlying Z/OS environment to make informed decisions. Correct approach analysis. The correct approach involves a systematic and controlled methodology for performance tuning. This includes thorough analysis of the query execution plan, identifying bottlenecks such as inefficient access paths, suboptimal join methods, or excessive I/O. The DBA should then propose and test changes in a non-production environment that closely mirrors production. This might involve creating or modifying indexes, adjusting DB2 subsystem parameters, or rewriting SQL statements. Crucially, any changes implemented in production must be carefully planned, with rollback procedures in place, and monitored closely post-implementation. This methodical approach minimizes risk, ensures that performance improvements are validated, and adheres to best practices for change management, which are implicitly expected in regulated environments to maintain data integrity and system reliability. Incorrect approach is analysis. Implementing a proposed index change directly in the production environment without prior testing in a representative non-production environment is a significant regulatory and ethical failure. This bypasses essential validation steps, increasing the risk of introducing performance regressions or system instability. Such an action could violate internal IT governance policies and potentially breach service-level agreements, SLAs, if it leads to system downtime or degraded performance. Applying a broad set of generic performance tuning recommendations from external sources without analyzing the specific query and its execution plan is also professionally unacceptable. This shotgun approach ignores the unique characteristics of the workload and the database schema, leading to potentially ineffective or even detrimental changes. It demonstrates a lack of due diligence and a failure to apply specialized knowledge, which could be considered a breach of professional responsibility to optimize efficiently and effectively. Ignoring the impact of the proposed index on other critical applications that might share the same tables is another critical failure. Database changes, especially those affecting data access, can have cascading effects. A failure to consider these interdependencies shows a lack of holistic system understanding and can lead to unintended consequences that impact other business functions, potentially violating compliance requirements related to system availability and data integrity across the enterprise. Professional reasoning. Professionals should approach performance tuning with a structured problem-solving methodology. This begins with clearly defining the problem and gathering all relevant data, e.g., query execution plans, system metrics. Next, hypothesize potential solutions, and critically, test these hypotheses in a controlled, non-production environment. The testing phase should simulate production load as closely as possible. Based on test results, a decision is made to implement the change in production, always with a robust rollback plan and a comprehensive monitoring strategy. This iterative and evidence-based approach ensures that decisions are sound, risks are mitigated, and the organization's operational integrity is maintained. Question 16. The monitoring system demonstrates a consistent spike in DB2 for Z/OS CPU utilization during the 9 a.m. to 11 a.m. business window, correlating with increased transaction volume. The DBA suspects a performance bottleneck, but needs to identify the most effective and least disruptive course of action. Which of the following approaches best addresses this situation? Option A. Immediately increase the size of all DB2 buffer pools to their maximum allowed values to ensure sufficient memory for data caching. Option B. Analyze DB2 accounting traces and SQL performance reports to identify specific resource-intensive SQL statements or application processes, then propose targeted tuning or optimization strategies. Option C. Restart the DB2 subsystem during peak hours to clear any potential memory leaks or transient issues. Option D. Escalate the issue to IBM support with a general description of high CPU utilization without performing any initial diagnostic analysis. The correct answer is B. Analyze DB2 accounting traces and SQL performance reports to identify specific resource-intensive SQL statements or application processes, then propose targeted tuning or optimization strategies. Explanation. The monitoring system demonstrates a recurring pattern of high CPU utilization on a critical DB2 for Z/OS subsystem during peak business hours. This scenario is professionally challenging because it directly impacts the performance and availability of a core business system, potentially leading to financial losses and reputational damage. The DBA must not only identify the root cause, but also implement a solution that minimizes disruption and adheres to operational best practices and IBM's recommended guidelines for DB2 on Z/OS. The correct approach involves a systematic investigation using DB2 diagnostic tools and performance monitoring utilities. This includes analyzing SMF data, DB2 accounting traces, and real-time performance monitors like DB2 Instrumentation Facility Interface, IFI, or third-party tools. The goal is to pinpoint specific SQL statements, application processes, or system configurations contributing to the CPU bottleneck. Once identified, the DBA should propose and implement targeted optimizations, such as retuning SQL, adjusting buffer pool configurations, optimizing sort operations, or considering workload management, WLM adjustments. This approach represents best professional practice because it is data-driven, minimizes risk by focusing on specific issues, and aligns with IBM's guidance for maintaining DB2 subsystem health and performance. It prioritizes system stability and user experience, which are paramount in a production environment. An incorrect approach would be to immediately implement broad, untested changes without proper analysis. For example, indiscriminately increasing all buffer pool sizes without understanding their current utilization and impact could lead to memory contention and further performance degradation, violating the principle of least privilege and potentially causing system instability. Another incorrect approach would be to restart the DB2 subsystem as a first-line response to high CPU. While this might offer temporary relief, it does not address the underlying cause and represents a failure to perform due diligence. It can lead to significant downtime, impacting business operations and violating service-level agreements, SLAs. Furthermore, it demonstrates a lack of understanding of root cause analysis, fundamental professional responsibility. A third incorrect approach might be to simply escalate the issue to a vendor without conducting any initial investigation. This shirks the DBA's responsibility to diagnose and resolve issues within their purview, failing to leverage available diagnostic tools and expertise. The professional decision-making process for similar situations should involve a structured problem-solving methodology. First, clearly define the problem and its impact. Second, gather all relevant data using appropriate diagnostic tools. Third, analyze the data to identify the root cause. Fourth, develop potential solutions, assessing their risks and benefits. Fifth, implement the chosen solution in a controlled manner, ideally during a maintenance window or with rollback capabilities. Sixth, monitor the system to confirm the resolution and prevent recurrence. This iterative process ensures that solutions are effective, efficient, and minimize disruption. Question 17. Analysis of the most effective strategy for a DB2 DBA for Z/OS to manage the implementation of a significant application enhancement that requires substantial database schema modifications and increased transaction volume, considering the imperative to minimize production downtime and ensure data integrity. Option A. Prioritize the application's functional requirements, deploying the schema modifications and new transaction logic to production as quickly as possible, and address any performance issues that arise reactively. Option B. Perform only basic unit testing of the new application code and schema changes, assuming that any database-specific issues will be identified and resolved by end users during normal operations. Option C. Conduct thorough performance testing and capacity planning in a pre-production environment that closely mirrors production. Develop and test a comprehensive rollback plan, and implement the changes using a phased rollout strategy with continuous post-implementation monitoring. Option D. Implement the changes directly into the production environment during a scheduled maintenance window, relying on the application development team's assurance of functional correctness and assuming minimal performance impact. The correct answer is D. Implement the changes directly into the production environment during a scheduled maintenance window, relying on the application development team's assurance of functional correctness and assuming minimal performance impact. Explanation. Scenario analysis. This scenario presents a common yet critical implementation challenge for a DB2 DBA for Z/OS, managing the impact of a significant application change on database performance and availability. The challenge lies in balancing the need for rapid deployment of new application features with the imperative to maintain a stable and performant production environment. A DBA must not only understand the technical implications of the change, but also navigate the organizational pressures and potential risks to business operations. The absence of a comprehensive testing strategy and a clear rollback plan amplifies the risk, demanding a proactive and risk-aware approach. Correct approach analysis. The correct approach emphasizes a structured risk mitigation strategy aligned with best practices for database change management. This involves thorough pre-implementation analysis, including performance impact assessment and capacity planning, to identify potential bottlenecks. A robust testing phase, encompassing unit, integration, and user acceptance testing in an environment mirroring production, is crucial for validating the application changes and their database interactions. The development of a detailed rollback plan, tested and validated, ensures business continuity in case of unforeseen issues. Finally, a phased or controlled rollout, coupled with continuous monitoring post-implementation, allows for early detection and resolution of any emergent problems. This approach represents best professional practice by prioritizing data integrity, application availability, and minimizing business disruption, all of which are implicitly or explicitly supported by general IT governance principles and the need for due diligence in managing critical systems. While specific Z/OS or DB2 regulations might not dictate this exact process, the underlying principles of risk management and operational stability are universally expected of IT professionals managing production systems. Incorrect approaches analysis. Implementing the change directly into production without adequate testing or a rollback plan represents a significant regulatory and ethical failure. This approach disregards the fundamental responsibility of a DBA to protect the integrity and availability of the data and the systems that manage it. It exposes the organization to substantial business risk, including data corruption, extended downtime, and financial losses, which could lead to breaches of service-level agreements and reputational damage. Such a cavalier attitude towards change management is unprofessional and could be construed as negligence, especially if it leads to a critical incident. Deploying the change with only basic unit testing and assuming the application developers have covered all database interactions is also professionally unacceptable. This approach abdicates the DBA's responsibility for database-specific performance and stability. It fails to acknowledge that application logic can have unforeseen and detrimental impacts on database resource utilization, locking mechanisms, and query performance. The absence of integration and performance testing in a production-like environment means critical issues could go undetected until they impact live users, leading to the same negative consequences as the first incorrect approach. Focusing solely on the application's functional correctness without considering the database's performance implications is another failure. While functional correctness is important, a DBA's role extends to ensuring the database can efficiently support the application's workload. Ignoring performance aspects can lead to slow response times, increased resource consumption, and potential system instability, even if the application functions as intended from a purely logical standpoint. This oversight can lead to user dissatisfaction and operational inefficiencies, undermining the overall value of the application change. Professional reasoning. Professionals should adopt a risk-based approach to change management. This involves 1. Understanding the scope and potential impact of the change on the database environment. 2. Identifying and assessing all potential risks, including performance degradation, availability issues, and data integrity concerns. 3. Developing and executing a comprehensive testing strategy that includes performance and stress testing in a production-like environment. 4. Creating and validating a detailed rollback plan to ensure rapid recovery in case of failure. 5. Implementing changes in a controlled manner, often with phased rollouts and continuous monitoring. 6. Communicating effectively with stakeholders throughout the change process. This systematic approach ensures that changes are implemented safely and efficiently, minimizing disruption and maximizing the benefits of the new application features. Question 18. The audit findings indicate a pattern of ad hoc requests from a business unit for direct access to sensitive customer data within DB2 for Z/OS, bypassing established data access request and approval workflows. A manager from this unit has now directly asked you, the DBA, to grant their team read-only access to a specific table containing personally identifiable information, PI, for an urgent analysis. Stating that the formal process is too slow, what is the most appropriate course of action for the DBA? Option A. Advise the manager that the formal request process must be followed and refuse to grant access until it is completed without offering further assistance. Option B. Attempt to extract the specific data requested by the manager and provide it to them directly without granting them direct table access to expedite the analysis. Option C. Immediately grant the requested read-only access to the table, documenting the request and the manager's verbal authorization to meet the business unit's urgent need. Option D. Escalate the request to the Data Governance Committee and the Legal Department for review and formal authorization, explaining the urgency, but also the need for compliance with data access policies. Correct answer is C. Immediately grant the requested read-only access to the table, documenting the request and the manager's verbal authorization to meet the business unit's urgent need. Explanation. Scenario analysis. This scenario presents a professional challenge because it involves a conflict between a perceived immediate business need and established data security and privacy regulations. The DBA is caught between a directive from management that could lead to a compliance violation and their professional responsibility to uphold data integrity and regulatory adherence. The pressure to deliver quickly can obscure the long-term risks associated with unauthorized data access and potential breaches. Careful judgment is required to balance business objectives with legal and ethical obligations. Correct approach analysis. The correct approach involves escalating the request through the proper channels, seeking clarification and authorization from the appropriate data governance or legal department. This upholds best professional practice by adhering to the principle of least privilege and ensuring that any access to sensitive data is documented, authorized, and compliant with relevant regulations. In the context of Z/OS and DB2, this aligns with the security controls and audit trails expected by regulatory frameworks governing data handling, such as those that might be enforced by internal audit or external compliance bodies. It prioritizes data protection and regulatory compliance over expediency. Incorrect approaches analysis. One incorrect approach is to directly provide the requested access without proper authorization. This is a significant regulatory and ethical failure. It violates data privacy principles and potentially breaches regulations that mandate strict controls over sensitive data access. Such an action could lead to severe penalties, including fines and reputational damage, and would demonstrate a disregard for established security protocols and the DBA's professional duty of care. Another incorrect approach is to ignore the request, assuming it will go away. This is also professionally unacceptable. It fails to address a potential business need, and more importantly, bypasses the opportunity to educate management on the risks and proper procedures. This inaction can lead to further unauthorized requests or a breakdown in communication and trust, ultimately hindering effective data governance. A third incorrect approach is to attempt to fulfill the request by circumventing security controls or using unauthorized tools. This is a severe ethical and regulatory violation. It demonstrates a lack of integrity and a willingness to compromise system security, which is a core responsibility of a DBA. Such actions would not only be non-compliant, but could also introduce vulnerabilities into the system, leading to data breaches and significant legal repercussions. Professional reasoning. Professionals in this situation should employ a decision-making framework that prioritizes compliance and ethical conduct. This involves 1. Understanding the request and its potential implications. 2. Consulting relevant policies, procedures, and regulatory requirements. 3. Communicating clearly and professionally with stakeholders, explaining risks and alternatives. 4. Escalating the issue to appropriate authorities when faced with conflicting directives or uncertainty. 5. Documenting all communications and decisions. This structured approach ensures that decisions are informed, defensible, and aligned with professional standards and legal obligations. Question 19. Governance review demonstrates that a critical DB2 for Z/OS subsystem is experiencing significant performance degradation, impacting key business operations. The lead DBA proposes a temporary workaround that involves bypassing certain security logging mechanisms to expedite a data refresh operation, citing extreme business pressure to restore full functionality immediately. What is the most appropriate course of action for the DBA to take? Option A. Restore the subsystem from the last known good backup without further investigation or documentation, as this is the fastest way to resolve performance issues. Option B. Immediately implement the proposed workaround to restore service, documenting the deviation from standard procedures after the fact. Option C. Proceed with the workaround without explicit authorization, assuming that the business urgency overrides standard security protocols in such critical situations. Option D. Escalate the situation to management and security, requesting an emergency change request with a clear justification for the temporary bypass of security logging, and proceed only after receiving explicit authorization. The correct answer is B. Immediately implement the proposed workaround to restore service, documenting the deviation from standard procedures after the fact. Explanation. Scenario analysis. This scenario presents a professional challenge rooted in the conflict between immediate operational needs and long-term data integrity and compliance. The DBA is under pressure to restore service quickly, which is a valid business requirement. However, the pressure to bypass established security and auditing protocols for expediency creates an ethical dilemma. The challenge lies in balancing the urgency of the situation with the DBA's responsibility to uphold data governance, security, and regulatory compliance, which are paramount in a Z/OS environment where data integrity and auditability are critical. The potential for unauthorized access or data manipulation, even if unintentional, carries significant risks. Correct approach analysis. The correct approach involves adhering strictly to established change management and security procedures, even under duress. This means documenting the incident, the proposed solution, and obtaining the necessary approvals before implementing any changes, especially those that involve bypassing security controls or auditing. This aligns with best professional practices for DB2 DBAs on Z/OS, which emphasize a controlled and auditable environment. Regulatory frameworks and internal governance policies typically mandate such controls to ensure data integrity, prevent unauthorized access, and facilitate audits. By following the documented procedures, the DBA ensures that the recovery process is transparent, accountable, and defensible, minimizing the risk of future compliance violations or data breaches. This approach upholds the principle of least privilege and the importance of a robust audit trail. Incorrect approach is analysis. Implementing the change without proper authorization or documentation represents a significant regulatory and ethical failure. This bypasses the established change control process, which is designed to prevent unintended consequences and ensure that all modifications are reviewed and approved by relevant stakeholders. Such an action would violate internal governance policies and potentially external regulations that require auditable IT processes and data security. It creates a shadow IT operation, making it impossible to track the exact changes made, who made them, and why, which is a critical deficiency in any compliance audit. Restoring from a backup without verifying its integrity or documenting the process is also a failure. While restoring from backup is a standard recovery procedure, doing so without proper validation and documentation can lead to data loss or corruption if the backup itself is flawed. It also circumvents the audit trail, as the specific actions taken during the restore might not be recorded or verifiable, leaving the organization vulnerable to accusations of negligence or non-compliance. Ignoring the security implications of the proposed bypass and proceeding with the change solely based on the urgency of the situation is a direct violation of data security principles and likely regulatory requirements. Security controls are in place to protect sensitive data, and bypassing them, even temporarily, exposes the data to unacceptable risks. This demonstrates a lack of due diligence and a disregard for the organization's security posture and compliance obligations. Professional reasoning. Professionals in this role should employ a decision-making framework that prioritizes adherence to established governance and security protocols. When faced with an urgent situation, the first step is to assess the immediate impact and potential risks. Then, consult the documented procedures for incident response and change management. If the standard procedures are insufficient or too time-consuming for an emergency, the professional should escalate the situation to management and security teams to seek expedited approval for a deviation, ensuring that any deviation is fully documented and justified. The decision-making process should always involve a risk assessment, consideration of compliance implications, and clear communication with all relevant parties. The ultimate goal is to resolve the operational issue while maintaining the integrity of the data and the organization's compliance posture. Question 20. Research into the ethical responsibilities of a DB2 DBA for Z/OS when encountering a situation where a performance bottleneck is suspected to be related to the encryption or decryption of sensitive customer data, and a quick resolution is urgently required by business stakeholders. The DBA has the technical capability to temporarily disable encryption for testing purposes to isolate the performance issue, but this action would bypass established security protocols and potentially expose sensitive data if not immediately reversed. Option A. Share administrative credentials with a trusted business stakeholder who has a vested interest in the performance improvement, allowing them to assist in disabling and re-enabling encryption. Option B. Temporarily disable encryption for testing, immediately document the action, and escalate to the security team for review and authorization of the temporary bypass, ensuring the encryption is re-enabled as soon as the performance test is complete. Option C. Proceed with disabling encryption without immediate notification to the security team, focusing solely on resolving the performance issue as quickly as possible to meet business demands. Option D. Refuse to address the performance issue until a formal security review and approval process for any potential encryption bypass is completed, even if it means significant business downtime. The correct answer is B. Temporarily disable encryption for testing, immediately document the action, and escalate to the security team for review and authorization of the temporary bypass, ensuring the encryption is re-enabled as soon as the performance test is complete. Explanation. Scenario analysis. This scenario presents a classic ethical dilemma for a DB2 DBA on Z/OS. The challenge lies in balancing the immediate need for system availability and performance with the long-term integrity and security of sensitive data. The DBA is privy to information that could be exploited, and the pressure to resolve an issue quickly can lead to shortcuts that compromise ethical and regulatory standards. The core conflict is between operational expediency and data governance responsibilities. Correct approach analysis. The correct approach prioritizes data security and compliance with IBM's recommended practices and relevant data protection regulations, which, for Z/OS environments, often align with U.S. federal and state laws concerning data privacy and security, such as HIPAA for healthcare data or PCI DSS for financial data, if applicable to the specific data being handled. By escalating the issue to the security team and adhering to established change management procedures, The DBA ensures that any modifications are reviewed, authorized, and documented. This upholds the principle of least privilege and maintains an audit trail, which is critical for regulatory compliance and preventing unauthorized access or data breaches. This approach aligns with the ethical obligation to protect data entrusted to the DBA's care. Incorrect approach is analysis. An approach that involves directly modifying sensitive data without proper authorization or security review is a significant regulatory and ethical failure. This bypasses established security protocols, potentially exposing the data to unauthorized access or corruption. It violates the principle of data integrity and confidentiality, which are cornerstones of data protection regulations. Such an action could lead to severe penalties, including fines and reputational damage, and would be a breach of professional conduct. Another incorrect approach, which is to ignore the potential security implications and proceed with the performance tuning without consulting security, represents a failure to exercise due diligence. While the intent might be to resolve a performance issue, neglecting the security aspect of data handling is a direct contravention of data protection principles. This can lead to inadvertent data exposure or compromise, even if no malicious intent is present. It demonstrates a lack of understanding of the DBA's broader responsibilities beyond just performance. Finally, an approach that involves sharing sensitive system credentials or access information with unauthorized personnel to expedite the resolution is a critical security and ethical lapse. This directly violates access control policies and increases the risk of unauthorized system modifications or data breaches. It undermines the trust placed in the DBA to safeguard sensitive information and systems. Professional reasoning. Professionals in this situation should follow a structured decision-making process. First, identify the core problem and its potential impact, considering both operational and security aspects. Second, consult relevant documentation, including IBM's best practices for DB2 on Z/OS and any internal security policies or regulatory requirements applicable to the data being managed. Third, escalate the issue to the appropriate stakeholders, such as the security team or management, providing a clear and concise explanation of the problem and potential solutions. Fourth, adhere strictly to established change management and incident response procedures. Finally, document all actions taken and decisions made for audit and review purposes. This systematic approach ensures that decisions are informed, ethical, and compliant.